So far, obviously, we've completed Chapter 7, and if you recall, Chapter 7 was all about solving for various lengths and angles in right triangles. Okay, so by the end of today's lesson, the hope is that you're able to successfully use trig to solve non-right triangles. And so just something to note here, okay, the trigonometric ratios that we've learned so far, okay, so sine, cosine, tangent, right, SOHCAHTOA, and then inverse sine, inverse cosine, and inverse tangent when we're solving for angle measures, those trigonometric ratios only work in right triangles. So we're going to look at two different laws over the course of the next couple days here called the law of sines and the law of cosines. And the advantage and the purpose of looking at these laws is that they can be used to find angle measures and side lengths in a non-right triangle. Okay, so in other words, the law of sines and the law of cosines are universal. They work in any triangle. So the first one we're going to look at is the law of cosines. I'm going to have to scroll through a few pages here. Oh, just passed it. There we go. Okay, so the law of cosines, here's what it says. Okay, it says if triangle ABC has sides lengths of A, B, and C, okay, then these three things are true. And I don't like the idea of thinking about it in terms of three different things. So what I'm going to use is I'm just going to go ahead and use this first one all the time. So I'm gonna forget about those two. Okay, those are true, but you'll see why I'm going to do that here, hopefully, in the next couple examples. So you have to know this formula. You'll notice the first portion of it, a squared equals. Actually, I take that back. I'm not going to use that first one. The one I'm actually going to use, and you'll see why in a second here, the one I'm going to use is this last one here. Because if you notice, excuse me, c squared equals a squared plus b squared, that's just the Pythagorean theorem. So you start with the Pythagorean theorem, and then you have to add on this minus 2ab cosine c. All right, and again, we'll look at some examples here so that this makes sense, hopefully. All right, so moving forward here, first example we're going to look at, it says use the law of cosines to solve each triangle. So I have to solve the value of b. I got to find the value of b here. Okay, and you'll notice you're going to use the law of cosines if you're given side, angle, side. Okay, so if you're given side, angle, side, we're going to use the law of cosines. And so what you do is you start off with, remember the formula, Pythagorean theorem, c squared equals a squared plus b squared, and then you have to subtract off 2ab cosine c. Okay? The big thing you have to recognize here is that this little c and the angle c are across from each other. Okay, so obviously in this diagram, I'm going to be using this angle here. The side across from that angle is b. So when I plug these things into my formula, this little b here actually represents my c squared. So I have b squared equals, your other two sides are interchangeable. So 45 and 43, you could write them in any order. So I have 45 squared plus 43 squared minus 2 times 45 times 43 times the cosine of 88 degrees. And so from there, what I'm going to tell you to do is I'm going to have b squared equals, and I'm just going to go ahead and grab a calculator, and I'm going to plug all of this in at one time to make sure I don't make any silly mistakes. Okay, so in other words, I'm going to do 45 squared plus 43 squared, and then I'm going to go ahead and plug in minus 2 times 45 times 43 times cosine of 88. See what we get here. I believe we should get b squared equals 3603.88. That's roughly, it's an estimate. Okay, and then I take the square root of both sides, and so the value of b in this diagram is roughly 3603.88, square root of that. So I'm thinking we're going to be pretty close to 60.03 for the value of b there. And then I look back at my diagram and I say, does that make sense? Well, if this is 88, chances are that's going to be my biggest angle. Okay, and so it should make sense that the longest side's across from the largest angle, and 60 is bigger than 45 and 43, so I'm pretty sure we're going to be good to go there. All right, so again, use your calculator to your advantage. Don't make any silly mistakes when you're going through and solving this. Okay. All right. This one, if you're in my regular geo class, this one is probably not as applicable to you. I don't think I'm going to ask you any of these type of problems finding the angle measure. However, it's worthwhile to sit in and look at this lecture here just so you're familiar with it and you can see kind of a review of algebra skills. So it says find the measure of angle A. So here's the measure of angle A. All right. It's not a right triangle, so I can't use inverse sine, inverse cosine, inverse tangent yet. I'm going to eventually. So what I have to do is it's a non-right triangle, so I have to use either the law of sines or law of cosines. And since I don't know any other angle measures, I have to use the law of cosines. So again, what I'm going to do is I start with my formula. So Pythagorean theorem minus 2ab cosine c. And I recognize that, again, this big C, that angle, is across from the little c. And so the angle I want to find is angle A. So I know that that's going to be my big C. My little c is going to be that 23 since it's across from my angle. So I have 23 squared equals, and again, 27 and 16 are interchangeable. 27 squared plus 16 squared minus 2 times 27 times 16 cosine of angle A. That's what we're trying to find. And so now you'll notice we're going to have to do a little bit of algebra here. Okay, so on the left-hand side, I have 23 squared, which is 529. On the right-hand side, I have 27 squared, which is 729, plus 16 squared, which is 256, minus 2 times 27 times 16 is 864 cosine A. People, do not, okay, I'm actually going to go one more step before I stress this point. So I have 529. Over here I want to collect like terms, so I'm going to go ahead and add these two numbers together. So I have 729 plus 256, and that leaves me with 985 minus 864 cosine A. All right, this is where I want to stress this. Do not subtract those two values. Okay? Think of this as 864 times x. If you had 985 minus 864x, you would never subtract those numbers. I can't tell you how many people make that mistake. Do not subtract those numbers. Algebraically, you can't do that. So I got to drag everything to one side. So the first thing I'm going to do is I'm going to subtract this 985 from both sides. So where am I left at here? On the left-hand side, I have 529 minus 985, and that's negative 456 equals, and so these are gone, so I have negative 864 cos A. I got to get A all by itself, so I got to divide by the negative 864. Sorry about that. So negative 864 on both sides. And when I do that, I have negative 456 divided by negative 864, hit enter, I get a positive, and I don't know what this is as a fraction, and as a matter of fact I'm using a calculator that I'm not crazy familiar with, and so I don't even know how to, maybe I do. Looks like this is 19 over 36 equals the cosine of A. And now that I'm down here, again, we're at this point, so I got to get rid of this cos, and hopefully we recognize the only way to get rid of cosine is to do the inverse cosine of both sides. And I'm going to come back up here now, so I have A equals the inverse cosine, so cos negative 1 of 19 over 36, and now I just plug that into my calculator, and I find that my angle measure is roughly, let's see here, 58.14 degrees, okay, to the nearest hundredth. So again, you'll notice when you're using the law of cosines, if you are solving for an angle measure, it's much more extensive. There's a lot more work involved. You have to actually subtract and divide and then use inverse cosine and go from there, okay? So again, if you have to go back and rewatch that portion there, it might be a good idea for you to do that. All right, it says find the measure of angle C. So again, if you're in my regular geo class, I wouldn't worry about this example too much. But again, still worthwhile to take a look. I'm actually going to go one more slide here to see. Okay, we're going to do this one here. Okay, so all of you should be paying attention to this one. So it says find the length of F. Okay, well again, it's not a right triangle, so I can't use SOHCAHTOA. I have side angle side, right? Side angle side. So that tells me to use the law of cosines. c squared equals a squared plus b squared minus 2ab cosine c. Identify your angle that you're using. I'm using the 46. The side across from that is my f. That tells me that f is my little c. So I have f squared equals, a and b are interchangeable. 9 squared plus 12 squared minus 2 times 9 times 12. And then cosine of my angle. My angle here is 46. And there's a couple ways to do this. As I said in the first slide, you may just want to plug everything into your calculator at once. If you're not that kind of person, if you want to simplify everything down, that's fine. So I have 81 plus 144 minus, I have 2 times 9 times 12, which is 216 cosine 46. And now, again, from here, I wouldn't mess around anymore. I would just plug this into your calculator and get a decimal, okay? So you have 81 plus 144 minus 216 times cosine 46. And I'm pretty sure I just goofed something up. Hold on one second. I'm going to go actually one more step. Again, I apologize. The calculator I'm using is not a great calculator. And then I'm just going to get decimal here. So I have 216 times cosine 46. And I got 150.05. And so I know that f squared equals 225 minus 150.05. That's 74.95. And finally, I have to square root at the end, which a lot of people forget, so don't forget that. So your value for f here is roughly, let's see here, square root 8.66. Should probably have units on here, inches. Okay? So f is 8.66 inches. Again, that is probably more realistic of an example that you should be expected to do on the quiz next week when it comes to law of cosines, especially if you're in my regular class. If you're in my honors, you should be prepared to solve for an angle measure as well. Okay? Let's see here. I don't know if I have another one. No, that's just a worksheet. So what I'm going to do is I'm actually going to go back one more slide here. So if you're in my regular geometry classes, you could probably stop the video now because I'm just going to do this one last example of finding an angle measure. Okay, so again, if you're in my honors class, you might want to stay tuned here. So it says find the measure of angle C. Here's my angle that I'm using. That's my little c. So I know I have c squared equals a squared plus b squared minus 2ab cosine c. I've identified my big C and my little c. Everything else kind of falls into place. 19 squared equals 11 squared plus 17 squared minus 2 times 11, 17. I'm going to run out of room here. Cosine C. And now I just start plugging away. All right, so I have 19 squared, which is 361. I have 11 squared plus 17 squared. Whoops, wrong button. 11 squared plus 17 squared equals 410 minus 2 times 11 times 17 is 374 cosine C. I'm going quickly, I know, because, well, I just want to get this video done here in a second. So subtract from 410 on both sides. So 361 minus 410 is negative 49 equals negative 374 cosine C. Divide both sides by the negative 374. So those guys will cancel. So the cosine of C is equal to negative 49 divided by negative 374. Let's see here. As a fraction, I got, let's see here, 49. Okay, so it doesn't reduce at all. Just 49 over 374. And again, I got to get C by itself. So at this point, I got to use my inverse. Okay. And you should know that because, again, right at the beginning, we know we're solving for an angle measure, so I know I'm going to have to use the inverse at some point. So the measure of angle C is roughly, let's see what we got here. Inverse cosine of 49 over 374 tells me it's 82.47 degrees, roughly. So again, I know that last example there was pretty quick, but I just wanted you guys to be able to have it there to look at over the course of the weekend or at your own convenience, I should say, really. So again, any questions you have on the law of cosines, have them ready to go tomorrow, and we'll look at plenty of examples to get you guys comfortable with it in class tomorrow.